Another draft physics video production. Alright, comments. They're really not on the subject, so it's always a problem. I guess I'm just going to have to start deleting and blocking and whatever because it's just useless junk. So this Tea Party guy, I've given so much latitude to. I've tried to explain this basic idea that this is a physics channel. Yes, physics has a consequence in terms of, some physics, you'll figure out that it's a deterministic universe, that we're just robots, that it's just a mechanical system, blah, 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 blah. That's sort of the inevitable consequence of doing physics correctly. But whatever, I do that crap on the other channel, and yes, the other channel's in Google purgatory at the moment, so, I'm not reading comments there. But regardless, you can email me if you really must, if you have to stay off the subject and get personally tutored in reality. But really, this is it. So one more of these comments that are off the subject, and I'm just going to block you. Okay, sorry, but that's the way it's going to be. I'm really not here to answer these kind of questions. It's not the purpose of this channel, shithead. Is it your opinion that after you die nothing happens? Well, no, lots of stuff happens, but none of it is supernatural. Okay, nothing magical happens. You don't get entangled with the moon, and the moon doesn't cry, and none of this wooey crap happens. You just do what every other dead thing does. You become part of something else. I mean, right now there's a bunch of dead people inside of you. Okay, a bunch of your cells have been other people's anuses and vaginas and all kinds of, you've probably got other people's sperm in you. I mean, you got lots of stuff inside of you that's been somewhere else. That's what happens. The little bits float around and go someplace else, jackass. But the pattern that was you, I mean, the combination of little bits, the exact words, just like letters. I can cut these letters off of here and I can spell other words like, jackass or whatever. Whack ass, something. I can spell something with those letters. Something else. And that's all you are. You're just a pattern of letters. The letters get disconnected when you die. You decompose. Little microbes eat you to pieces, shit you out, and your little bits, your little letters float into some other pattern somewhere else. This is not a God question. Yeah, this whole fucking conversation has nothing to do with physics, shithead. It's a question of energy. No, it isn't. Everything's a question of any energy, jackass. Everything in the fucking universe right now is a question of energy. So it just doesn't mean anything. It's just baby talk. There's nothing special about our energy. We have no more energy than all the other molecules and things farting around. The only thing we are is more animated. That is where our vibrations, our movement is more obvious, like all the other mammals and all the other reptiles and all the other amphibians and all the other fish, which is your real ancestry. It's been said that energy is never destroyed. So again, you're just mixing subjects. Yes, and that's true of every single physical object in the universe. There's nothing special about the energy in a human being, but simply transferred from one form to another. There really aren't forms of energy. There's just movement. Period. That's it. And the argument is that the universe starts with movement. The little bits, the energy, the forces are the things moving. And the dumb little matter bits are just things that have an ability to exchange this way for that way. They collect a certain amount of it, and they don't, then they have to exchange to collect. That's all. They have 10 nickels in their pocket. Okay, and all you can do is they can exchange a 1942 nickel for a 1953 nickel. And so at any one time, the average nickel date changes. But that's it. The average direction of an electron or proton changes because it absorbs a different kind of momentum and essentially slows it down, traps it, mixes it with some others, and they decide as a collective which way they're going. We are electric in nature. Fuck you, baby talk. Our heart runs on a small, yes, voltage. It's really not small voltage. It's really a pretty good voltage. But regardless, it's totally irrelevant to anything. Yes, we're a mechanical machine built over hundreds of millions of years. The argument's been made. And it's made of a bunch of different physical changes to things that happen through this idea of a DNA molecule that reads a blueprint and builds things. And the blueprint evolves. We don't evolve. We're the test instruments. We're not the manufacturer. Okay, we're not manufacturing our DNA. Okay, we're merely the byproduct of the machine that's making the blueprint. Where does the energy we go after? So again, just this is just baby talk. This is something you should know about when you're in grammar school. They tell you the facts of life, and you have to deal with this fact that you're a biological organism made out of chemical compounds, and some of the chemistry gets more complex and some of it gets less complex after you die. You go back into the equilibrium of the system, and that's it. There's nothing special about your energy. So anyway, last I'm doing this crap. Okay, it's not physics, it's baby talk, it's wooey nonsense. It has nothing to do with explaining experiments and results. You want to talk about ESP or some special powers you have, then do it some fucking place else, because this ain't the place it's going to happen. Alright, your fake evidence, your fake words, your fake jargon, your fake misinterpretations of basic concepts are just not my problem, asshole. Go get a grammar school education and then come back and have your conversation. I mean, you really don't understand anything about thermodynamics. You don't understand anything about how the ecology works. That the molecules just move. The clouds are made out of water that was in streams and oceans. You don't understand that concept. Anyway, you obviously have a religious belief bias, so any answer given isn't going to concur with your worldview. Clearly, he has a desperate need to find bullshit to blame, I guess. I mean, that's the irony of it. He's acknowledging, well, that's not a very nice answer, okay, that I'm just a dumb robot mechanically processing a world like a soda machine. Oh yes, a soda machine that can sing and dance, or a soda machine that can ask irrelevant questions. When you die, your remains will be transferred back to the soil to feed all the plants and insects and bacteria. Well, again, feeding them in what sense? Okay, they just borrowing the energy too. They're just taking advantage of an imbalance. Unless you decide to go the human candle way, what does this mean? Your body will produce a lot of energy release under that process when you left with your ashes. So again, there's no special amount of energy, really. I mean, your body gets cold rather fast because it's not going to make them metabolizing the sugars and creating heat. But you don't end up with a bunch of nuclear reactions. I mean, we don't blow up like a nuclear bomb or something. So nothing incredibly special is happening with any transfer of energy. Nothing more special than what happens all the time. Proteins are made, proteins are broken. Proteins are made, proteins are broken. Wood burns, happens all the time. Carbon cycle. You don't have to be scared of the nothingness. Well, I think you should be damn scared of the fact that the whole thing is a Borgish nightmare. At the end of your days, as it's exactly the same as the nothingness you didn't experience before you were born. Well, yes, you certainly don't have to be afraid of the fact that you're going to be concerned that you're going to jail or something. Okay, dying doesn't mean you go to jail. It doesn't mean you go to some purgatory and say, oh shit, I'm not alive anymore. Oh, there's no women here. This place is boring. Yeah, none of that stuff happens. You don't go to some prisoner camp or something. So, yes, nothing to fear. Alright. So, the energy it takes to be alive dies with the body. No longer relevant. Again, it's as relevant as all the other dead people that you're made out of. All the other dead things you're made out of. I mean, you could have some, a little bit of Tyrannosaurus anus. This, a few chemicals that were right there, in the Jurassic, are floating around inside of you. Man, that's messed up. Why? Because your mommy lied to you, I guess. The only reason why it's messed up is because your mother gave you such a messed up drawing of reality that you think reality is messed up. Oh, okay. Makes you ask yourself, what the fuck are we going through all this shit for? Well, I don't know what you thought you were going through it for. So I'm surprised you're surprised, okay? Because it didn't take much imagination on my part when I was 5 years old to figure out this whole thing is a farce, man. All these people just lie about everything. God's will be done. No, it has nothing to do with that. It has to do with there was a nail in his tire, and the tire blew up, and the car flew off the road. It doesn't do with any fucking God's will. What, God sprinkles nails on the road? Fuck him in the ass, then. Just lame, man. Fuck you, man. I'm gonna just play with my electronics till this shit show is over. Yeah, well, I don't know what electronics you can possibly even contemplate in any kind of constructive manner. Yep, when the body dies, the spark goes out. There's no spark. But anyway, you ask, what the fuck do we go through all this shit for? Which again infers purpose. We just happen to be through evolution and lots of time, yes. But we're still just robots. I mean, it's just so funny that people do videos about robots getting along with humans and all this kind of... It's just robots getting along with robots. We are robots. We have to be programmed. You have to teach us everything. I can think of far more pleasurable things to play with in life than electronics. Yes, exactly. But regardless... Alright, so he's voluntarily buzzing off. Okay, fine. But really, fuck you. I mean, I made it kind of clear. I really don't want to do this philosophy shit here, jackass. Okay. You are terrible. Well, gee, that's such an amazingly deep and revealing comment. It just says so much about me. Oh, wait a minute. No, it says a ton about you. That you're terrible. What kind of asshole, again, raised you? That you think this is how you can go through life, just going, that's the extent of your capacity to articulate yourself. I mean, you can't, you just walk out of the theater and go, that movie sucked, and you can't say why. You can't give somebody some clue, like, oh, it has too much red in it. Yeah, it's too much red. Too many red shirts. What's your complaint, asshole? I mean, it's just such bullshit. So do you think the two-slit experiment is grand evidence, nail in the coffin evidence that photons are waves and that they turn into wave functions and they magically interfere with their own function somehow to create a fucking on and off pattern, the simplest pattern in the universe, and that pattern can only be created by wave interference? You think that's really good science, huh? Then you're really an asshole. Fuck. Alright, Ken. Slightly off topic. Well, I really don't like that much. But I am interested in getting into physics. You inspired me. Well, that's good. I mean, people should just get into doing this reality thing, politics, everything is so full of shit. Everybody's so full of shit in terms of understanding how any system elementally works. Understanding how a system works means that gives you power to control it, to make it work better. You got to know your robot, know how to grease it, know how to maintain its function, keep it from rusting and whatnot. And all of this is critically important to our function is having right answers, not wrong answers. Which method do you prefer when you were learning? Well, see, that's the trick. It's not like I learned all of this recently. I mean, I did have a decent enough. I mean, as much as the school is useless, and as much as I couldn't have given a shit, and as much as I was stoned most of the time, some of it leaked in. I mean, they force you to hear this crap, and so you contemplate what they're saying, and you say, does that sound like something reasonable, or does it sound like something unreasonable? If it sounds unreasonable, then you go look into it and see, why do they believe this shit? You have to, if you're going to critique a religion, you sometimes have to read their Bible, at least some of it, to get the idea of it. And so, so it makes you curious when you say, why are they saying that? Because that makes no fucking sense. And then you find out that they're saying it because of some stupid slit experiment, that they don't even understand. It's just Newton's rings, and now they're calling it something else when it's exactly the same thing. Why are you calling it something else? All right, textbooks or online lectures. Everything is valuable to some extent, right? So, I mean, I'm reading a bunch of somebody nicely sent me a link to at least one biography of Faraday that's pretty good. So I'm reading that. And then I was reading some of Maxwell's crap. So, I mean, it all helps and give you a context. So if you're finding a problem, like this concept of a field line, and I was trying to see where it turned from field line to force, lines of force, and who came up with the jargon first. And I really haven't been able to find who came up with the jargon first. Funny thing is, Faraday did come up with a whole bunch of words like volti something or other. I mean, funny words that he made up that never stuck. As powerful as he was, he couldn't make his silly jargon stick anyway. Would you have any recommendations? Yes, the online lectures are really good, but the problem is they're just, they just pour on the mathematics, and they don't really pay any attention to the concept. So that's the downside of it. But the Feynman lectures are pretty good in terms of drawing pictures. Professor Lewin's videos are okay, but as I found out, most of the experiments are engineered to produce a result consistent with what they want to state is or claim to be the effect. And some of them are not really giving you the right answer. I mean, it's right answer for the wrong reasons. As some good physicists said about Huygens. Again, I apologize for posting a slightly irrelevant post. Yeah, well, people do this. They ask, what's the quickest way to learn everything really fast and without doing any work? Yeah, I don't know that. Okay, I'm old, and it's taken me a while, and I didn't get into all this crap until I'm pretty old. So, I don't know what to tell you. It's a little bit tedious. Again, I would say, you're best off watching my videos, frankly, because I've done all this hard work of listening to their jargon and their bullshit and realized, you got to cut this down to basic concepts and what you're really talking about. So I found that with Maxwell. Maxwell went through a whole convoluted explanation of Faraday's perception of field lines, and he was talking mostly about field lines, the lines that do curve from one thing to another, which are just the changes in the intensity or strength of something. Well, anyway, so he was using the same kind of argument that they do when they teach Einstein. When they teach Einstein, they reduce it to fluid dynamics. And so the whole thing just becomes a convergence. It just means that you have a drain in the middle of something, and then you have an endless supply of water on the outside of something, and you're really just talking about where does the fluid flow. So if I put a drain over here and a drain over here, how do the two drains interact? And that's all it comes down to. And Maxwell is doing exactly the same thing. And they're all doing this in the context where they freely admit that there seems to be a connection between gravity and electricity and magnetism, that they in charge. They have something in common. And that's before they even explicitly knew that that this fluid moves at the same speed. So in Maxwell's analogy, he was using a fluid that changed its speed, which later Maxwell was the one who discovered the fluid has a standard speed, the speed of light. So we'd have to change that analogy. But the very fact that they're using these analogies that just have to do with pressure, really, that you have a source on the outside and that you have a drain on the inside, and you're really just two opposite kinds. So what is draining from one thing is pushing from its perspective. But yeah, exactly the same, using exactly the same analogies. And so I'm just saying that's where you have to cut it to. You have to cut it to that, and you forget about this bent warp space crap. Forget about bent geodesics. Forget about all that complicated thing, and just recognize that what they're really saying is there's a vacuum cleaner inside of every piece of matter. When they're doing gravity, and that when they're doing the electrodynamics part, well, then they have to recognize that the drain can back up. So the source can be the destination, in the sense of the pressure can come from inside something and going out, or it can go in, and that's now where you have the difference. So now you have a fire hose, and then you have a drain over here, and that kind of thing. All right. Anyway, the whole video is just so. They can't even, 10 words, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10 words. And can't do it. Can't do it in any kind of, not only is it useless crap, but it can't even be typed correctly. The whole video is just unscripted, half-finished thoughts. So, again, based on what? What evidence do you have that that's what the whole video was? Yes, they're unscripted videos, but in a sense, they're highly note relevant. So again, I can just give a Faraday example. Faraday, when he first started doing lectures, they were all scripted, and then later he learned how to do them by just having a general plan, a bunch of notes that just basically tell these are the key points I want to talk about, blah 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 blah. And so that's, I guess, something you learn how to do when you're a little bit more of a professional. You don't have to have a script. But whatever, it's just half-finished thoughts. The channel's called Draft Physics, so I should be allowed to have half-finished thoughts in that context, but I would argue that they're really not half-finished. The arguments I've made are real. The questions I've asked are real. This is even, I think, one of the videos where I'm saying, why can't this be true, right? This is a why can't this be true video. Yeah, why can't this be true? So I'm asking a direct question in the video. The video is about a direct question, a direct challenge, and your response to the challenge is this mush. To ask some other irrelevant, not even a real question. Is the whole video that? Well, I guess the answer is no, you dumbass. I guess you'd have to watch it to know that, though. And then you'd answer my questions. That's the whole point of me asking the question, is to see if you have a possible answer. Is there any possible answer to my simple question? Why can't this be true? Well, why don't you point out the why? Why don't you point out the experiment that disproves it, or the logical argument that disproves it, or any of that? But instead you choose to do this nonsense. So really, you just block them, right? It's just no point. He really doesn't want to play by any kind of rationally fair rules here, right? Again, crap I could type on anybody. I can just, this snarky, useless crap, anybody could type anywhere. So we do have in the spam folder one humorist, okay, doing his little satire. I like your videos which tear apart clueless posters who talk without knowledge of physics. And again, that the example I would argue is Ken Wheeler is pretty unknowledgeable, or in the sense that he says he has every book and he's read every book, and yet he doesn't know simple things like the ferrocell, the little bits are magnetic and they're lining up like little magnets, and they're doing exactly what iron filings are doing. So how do you explain what you're seeing as anything other than just an optical illusion? I wonder if you would comment on this guy whose videos are a hoot to watch. Yeah, so he's pretending like he's talking about somebody else when he's talking about me. He is one of the most clueless buffoons out there. So again, more useless crap. So I should go based on your opinion. If somebody said that to me, oh, there's this guy who's a clueless buffoon, how much credibility would I give it when the average person says something like that, right? So that's even meaningless and funny in a sense, because no, most of the time when somebody else says it's clueless buffoonery, it's not out there, and just throws around a word salad of phrases. So again, the word salad I'm guilty of. So it would be nice to have some comparison. Why don't you show me the videos that aren't word salad, that are more word salad or less word salady than mine? So show me the physics videos where it's put in plainer language or plainer concepts than my videos. Just the challenge. You can't do it, right? So all you can do is talk shit. You can't even produce any. You can't even pretend to play fair. He is picked up by watching physics videos on YouTube. So just a statement that doesn't make any sense. Well, I picked up the idea of what the inverse square law, something light bulbs are doing, all the time. Not magical in any way. All right, Maxwell's equations, Einstein's field equations, elemental emergent vector space. I've never used the word vector space, ever. I use emergent, yes. But I mean, why would somebody say that when it's clearly not a concept I play with? Vector space. There's no vector space. It's bullshit. Field effect. I don't say anything like field effect. When did I ever use that in any of my videos? So he can't even do this joke, okay, with any kind of detail, being accurate in any way. Momentum conservation. Well, I use conservation, the word conservation, quite a bit. I don't know if exactly I say momentum conservation, because I don't think momentum conservation means much, because what you're really conserving is the force. Okay, the momentum of an object is just the fact that it has more of one force in it than another. So there's no real conservation of momentum. There's conservation of force. Feynman diagrams, yes, I've mentioned them. Lorentz transformation. Well, there's lots of transformations. As I pointed out, that is a piece of jargon, in the sense that all it is a drawing, okay, of something that maybe you shouldn't be drawing. Maybe you're really not going to understand the inverse square law by drawing a sloped line, right? I don't think. You're going to understand why it exists or how it's produced, because that curved line has really nothing to do with the straight line force that the inverse square law is based on. The square geometry, the very square geometry that the force is made by, isn't going to be illustrated in that curved line, because that curved line really isn't a curved line, right? At every point there's a specific amount of something, so it's more like a staircase anyway. Time dilation, etc. You name it. This clown throws in the phrase in his word salad presentation. So he's saying there's some other word salad I'm guilty of besides those phrases, that somehow there's other jargon I'm using. Like what? That there's three dimensions, up, down. I mentioned up, down, left, right, and forward, back a lot. So I guess that's word salad, to acknowledge the existence of three physical dimensions. You only have to watch 10 minutes into any of his videos before it becomes clear he has no clue what the words actually mean, and you demonstrate that with no evidence. And the person who, I bet, doesn't have any clue are the cowards who are afraid to come into this room. They're afraid to make response videos. They're afraid to make even an audio track on a video. They have no articulated response except this gibberish, this mush, this stuff that doesn't say anything, quotes nothing, cites nothing, just opines in some general way. I don't like it. All right, anyway. And the best part is when he yells at others. Now, clearly I don't yell at anybody but assholes, right? I mean, assholes making claims they don't back up with anything, any kind of evidence at all. And clearly I get irritated when I get misquoted or I get talked about in some kind of way that's completely a lie. So of course I yell at assholes. You want to show me the face of the one who's not an asshole. Show me the quote that was undeserved. Show me where I badmouth some honest commenter. To get basic knowledge before commenting on the subject. So just more crap, more stupid accusations where it seems like you people are the one clueless on the basic knowledge. You think water makes two waves in a single slit and interferes with itself. And guess what? Water doesn't do that, asshole. It's completely contrary evidence to your wave theory. The irony is delicious and hilarious. And I guess I'm just having the obvious contrary reaction, which is the idiocracy is frightening and depressing. That you think you have a right to do this nothing you did. You didn't fight, you didn't do anything in any fair manner, you didn't paraphrase, you didn't quote, you didn't do anything here except slander. I can't remember his name right now. I will post later when I remember his name. Gee, that's such a just all this work for a joke. Ha 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 ha. Aren't you fucking clever? Fuck off. So I won't bother reading any future tripe. If people can't type something rational, they can't make one single rational argument. So I'm just demonstrating to you. There's nothing, I haven't deleted anything else you haven't seen here. This is all they got. They can't make any kind of rational counter argument. All they can do is this shit. So this is the best they got. And it's really bad. Alright, so, yeah, I guess that's all there is. I don't know why YouTube keeps doing this, right? I click on public. Oh, it didn't do it this time. But it always puts this filter in. It's really irritating. Alright, so, so this is what I was getting to before, is this, see, this is a way of saying that these would be lines of force. So Maxwell draws these kinds of equations. I haven't found them yet in what paper, but he has them. They're part of the story. But when they say field lines, they're talking about like the lines that line up with iron filings. So that's what Faraday is talking about. And somewhere, like I said, this concept evolved, where this became what I would say is the argument for a field line diagram, where a line of force diagram, where you're basically acknowledging the existence of the inverse square law. Now the weird thing is I looked up Coulomb's law. I was looking for him because I was saying maybe he has some drawings, and then I found out that he's the one who first proposed that the force between charges is the same inverse square law that you see in gravity, and but apparently there's great controversy over the fact that he probably had no reason to claim it because his experiment couldn't detect it. His experimental method wasn't good enough to detect the with any kind of certainty, and so he was just basically saying it looks a little bit like it, so we'll just say it is. And that sort of gets into this, this subject I've been talking about in terms of how the function changes depending on which way an electron is moving or a charge is moving. As the charge moves, its profile changes, and that's the effect of the inverse square law, is that at a distance, usually something's at a distance, okay, because it's moving away from you, right? That would be one argument that could be made. And moving towards you, it's going to be getting closer to you, and so it's, but that would be, you can end up with the same effect in the sense that the magnitude of the force increases disproportionately, in the sense that it's 4 times the difference rather than half the distance 4 times change, versus half the distance half the change. And that, just as I stated before, I think, like, see, if I was having this conversation with a physicist, I think he could get the simple concept of the fact that we live in a three-dimensional world, and when you have forward dimension, the other two dimensions are both in the same plane. Two of the dimensions are always in the same plane from any perspective, and that of course any division, any separation, you would have to conclude it could happen in both dimensions, especially with spherical objects. So anything spherical, which is in a sphere, is essentially saying you have a center, a center that's equidistant from all the surfaces. And so this gets to Gauss in the sense that this idea that you can reduce everything to a point charge, essentially, and you just say whatever it is at its very center, and you can just measure distance and say distance will tell you how strong that center is, because you just expand the shells and realize that you're covering 4 times the area. All right. So yeah, so this idea that when something's moving is, as I pointed out, creates this phenomena that if you're looking at, say, an electron from one side or looking at it from the other side, depending on which way it's moving, it will look different to those two sides. So if it's moving this way, meaning it has more substance moving in this direction, that is more mass, essentially. So the argument would be that the real mass, not the what do they call it, the sitting mass, the there's another word for it, when it's not moving mass versus its practical mass. And so you could just make this argument with a bullet, that the mass of a bullet, is clearly only at the tip of the bullet. That's where all the mass is. And the sides get more and more transparent. The faster the bullet's going, the less impact it's having on the reality, the less you see of the bullet, right? So the faster the bullet's moving, the less photons that actually hit it, the less it can bounce to my eye, the more invisible, essentially, it's becoming from any other position, and all of its mass is essentially in one direction. But regardless, and mass just really has to do with the percentage of this that's moving in a direction, that is this force, So, so if something is moving towards you, there's less of this, and that's the key point, right? There's less of this. So, and this is something you can't hit, and there's more of this, and this is something you can hit. And so you're just making something easier to hit in the sense that there's more stuff going in a direction that you have some chance of interacting with. So there's more likely to be an interaction with something that's moving towards you than something that's moving away from you. And that's really the point of the inverse square law, in the sense that, the inverse square law being applied to electrodynamics is partially this fact that this object, this charge, changes as you change its motion, and that as it's moving towards you, it's really visible. As it's moving away from you, it starts to get invisible. And that relates to this bigger picture of the fact that you're like the magnet example. This is a good way to illustrate it. That if you have a coil, and you move a magnet into it, the speed, at which you move that magnet will create more energy. And they don't really have a great explanation for why that is. And I would argue that the reason why that works is because as you're moving something towards something that's got one of these charges on it, that has some sort of charge effect, that you're making it more visible, you're making it more real, you're making it essentially more reflective. So the idea would be is the electron, as it moves towards something, it becomes more and more likely to reflect whatever comes into it. And reflection would just be this exchange between, the arrow going this way. And so it's more reflective. The more you're moving it, the more reflective it gets. And that means all this energy comes right back as you get this reflection. And so if you're also going to be reflecting the energy, the fact that this is producing more reflections means it's going to look like it's bigger, it's heavier, it's more of something. So you're just back to the ping pong paddle analogy with a ball bouncing back and forth. Now see, these people say that's jargon, when no, those are illustrations of how you trap energy and how you make energy proportionally stronger. So essentially, you're not only bringing the paddles closer together, okay, which obviously makes the ball bounce more, but you're also increasing, okay, the number of balls that stay in the area. And that's the inverse square part. So it comes out to be the inverse square law, but it's doing it differently than the way gravity's doing it, you know, where it's you can understand it dimensionally, you know, that the like, and how light's doing it. Light is creating a certain number of photons. It creates that number from one small location, all right, and it's a certain number, and that same number when it's hitting some other place, obviously if I drew a bigger circle around that light, you could understand that there's fewer photons per square inch on that bigger surface, that further away surface. So if you just think of making bubbles around everything, you can sort of understand that if I think of the light bulb and then think about a clear sphere around it, and I put the sphere out further, and I put the sphere out further, you understand the same number of photons have to illuminate that bigger sphere. And so the photons are going to be further apart. And they're not just further apart this way, they're further apart this way. Alright, so that's the two-dimensionality part that gives you the square, that makes the square. The square is made out of things separating in two dimensions. You know, not only this way, but also this way. Alright. So here, the square part is, you have this distance that's getting halved. Okay, so you're making this distance half the distance, means twice as many interactions. So that's a 2. That's just a, you know, that's just an R rule. Okay, half the distance, half the an increase in the effect. You know, the R rule is that you're dividing R into something. And then, but then you have this added fact that if they're moving, okay, that's where you're increasing. Okay, so in the process of making them closer, it's where you're squaring it in the sense that you're adding another factor that multiplies the effect. So whatever this effect is, it gets multiplied by the fact that these things reflect more the closer they get. So I bring them twice as close to each other, I've increased their reflectivity by 2. So that's the other 2 that goes, you know, the other 2, the other doubling that you put together to get the inverse square effect. So it's made out of something else. So it's the similar effect, but it's made out of something else, and that's the key point is I'm making here is it's a similar effect that maybe they've never really established an explicit R squared rule. They just have it as a generality, and it's close enough in most cases. Close enough, so they don't need to be exact, because they have something that's close enough to the truth. Hopefully that was all in the diagram. I don't know, I should have I should have done better than that, yeah. So you might have missed some of it, but who cares? It wasn't anything too dramatic out there, but whatever. Yeah, in case you missed something. Sorry, I'm tired. I'm cold. Irritable. Yeah. I'm not in my perfect element. I have to wait till I get rich. Yeah. Anyway, so till next time, no, I'll do something else. I'll just take a pause. Yeah, that's what I'll do. Back. So I thought we'd do a little bit of an example of how the conversation should take place, in the sense that if I'm talking to somebody who has some knowledge of physics, and the crude facts of thermodynamics, the fact that it's a pressurized system, that's all we're really trying to describe, and that has some knowledge of this view, this way it's taught, the idea that it's a convergence gravity can be drawn this way, that every material object is a drain, and that there's a source in the universe, and that you can basically just follow the motion as being just fluid dynamics. How are these drains going to react and in the atmosphere of pressure, and that again now we have the example of Maxwell doing the same thing in terms of trying to illuminate Faraday's descriptions of lines of force. So let's just so the basic concept is we're just saying that there's this idea that the motion comes from something, the virtual photon or the bent space. So we have two non-explanations. So if we do what they do when they teach it, which is to resort to a model that's something like Mach gravity. So a regular physicist should know what that model is, and that's this model of the pressure on the outside, and everything that happens on the inside is just places where that pressure is disguised or transferred. So we're back to just this simple model. So and then if I take the idea of electrons and protons and just tell you that they don't do anything natively, that all they do is trap force. So the idea is that you have this force free coming from all directions, and that this thing, the electron or the proton, all it will do, all it's capable of doing is essentially keeping that stuff in here. It just traps it. You can think of it just being trapped in this raceway. So it's a cul-de-sac. It goes in and it doesn't come out. Alright, but when it goes in, it's exchanging. And that's the key point to know. So for a new car to get on the track, one of the other cars has to leave, in some direction. And that's all you're doing. It's just changing the disposition of this object. What things has it trapped? So in the last, 15 interactions, what went into this thing? And in free space, what'll go in is a random, randomized, even pressure overall of what goes in, and then what comes out will be also randomized. So in free space, it has just pretty much no identity all by itself. But the minute I put something else in the universe, that identity is going to change, because this thing's going to trap stuff, okay, that obviously was headed for this. And so stuff that was going to be part of the random world that this thing existed in, this thing's going to de-randomize it just by existing here, just by being in this. Wow, that's really quite crappy. Okay, this is stupid lighting. I gotta figure out how to make morning videos about this light problem. All right, so yeah, by existing, this thing's going to necessarily now and then trap something that was heading for this, and that this is now going to be shaded by, on this side, it's just not going to receive this energy, because by being trapped just means you could say slowed down, occupied, whatever, however you want to look at it. But the point is what was here doesn't get here, and that's going to have an implication on what this thing's going to be producing back at the world, because it's not going to be able to produce this because it didn't absorb that. If these guys don't go in, they can't come out. Okay, so this is now going to be radiating in these directions, and clearly it can't trap this, and so its disposition is it's going to definitely trap more stuff coming from this way than it's going to be able to trap coming from this way, and therefore this net movement, it's net what it's collected. So let's just say it collected this, and then it collected something going this way, and then it collected one going this way, and it collected one going that way, and then it has a net. If you add up all these, what's the net direction you end up with? And it's going to have a net direction, and because it's not collecting here, it's going to have a net direction towards the other object. And the same thing happened to this object. When this thing came into the universe, it's trapping energy going this way that will not get here. And the consequences of this is going to move towards it. And that's gravity. And, you know, that's the most elemental function is, I guess you would argue, this shadowing effect. And now to understand the electrodynamics is just to say, well, what if, okay, what if we make this object do two different things? So when the green stuff reacts, it just does this transfer thing. You know, it just, one guy jumps in, another guy jumps out, and the guy that jumps out will be, if you have a bias in a direction, you could figure out that the one that's jumping out is going to be likely to be somebody going that way. Okay, you know, that would be the bias. But it certainly depends on which way it comes in. If it comes in this way, the bias is it's going to come out this way. Okay, so let me highlight that. If it comes in this way and this thing's moving that way, the bias is clearly going to be in that way because there's more energy trapped going that way, so you're more likely to hit a car going that way. But you know, if the energy comes in this way, let's make it red just for the purpose of the drawing. Well, then you have to understand that most of the energy is going this way, but it can't hit that because it's going the same speed as those cars, so it doesn't hit cars going that way. It can only hit cars going this way or that way or that way, and there's less of those. So, you know, now it's more likely that if the energy is coming back, it's coming back in these directions, because there's not much likelihood it's going to be able to hit the cars going the wrong way. So it all kind of depends on these little subtle circumstances, but now you can get the idea, and then the idea of repulsion becomes kind of obvious. If I just make these rules, then the fact is, if these two objects are moving towards each other, this one's moving towards this one, that there's going to be a higher likelihood that they're going to just keep making exchanges back and forth with the same piece of energy, instead of going across the universe in a nice straight line. Instead, it's going to be doing this very unstraight line, which creates a whole bunch of interactions. So where it goes across the universe and just hits an object, there's only one interaction, right? Well, now there's a whole bunch of interactions, and all those interactions mean a change in the disposition, a change in its net velocity. And so unless there's a pretty strong force out here that keeps pushing, the object's now going to move away from each other. So they were moving towards each other, and now they're going to be moving away from each other because of this pressure rule. Well, anyway, so just by having these two forces that have two different kinds of interaction, so I really didn't go into the other force having the different interaction, but the different interaction would be, it doesn't just jump into the boat, okay, and let somebody free. So let me just draw that one more time just to illustrate, because that's the new edition. Well, that's the draft proposal, is that the two kinds of interaction. One interaction is it goes in, it creates a reflection, and the object takes the momentum. Pretty much. So, but this reflection can be in a different angle. The second way it can happen is that the energy goes in like that, and it hits something, and instead of one thing leaving this way and one thing leaving that way, instead of that happening, okay, the two things, which would be different colors, but let's not bother with that right now, would average that net, and both this would keep something going this way, and it would also emit something going that way. So these two directions are converted into two pieces of momentum going this way, one piece free and one piece inside the electron. So those are the two possible interactions. One is just a pure exchange, this goes in, something else comes out, and the other, the momentums are added, and both elements, element 1, okay, and element 2, do leave, but they both leave in the same direction, which conserves the angular momentum, if you want to use that term. So anyway, the directional momentum, it's a safer term. Alright, so now I think I've done enough. So why can't it be true? Why doesn't this simple model answer all the questions you need? It creates repulsion, it creates attraction, and then it creates the dipoles would just be doing the same thing inversely. So obviously if I mix a bunch of dipoles, take a bunch of magnets and move them in different positions that are inverse to each other, I end up with a net nothing. And that's the basic concept, that you're just neutralizing the two-force effect when you have a bunch of mixed polarity, like in gravity. So gravity just means that all the atoms are mixed polarity, so all the red and green stuff is all oriented in random directions. So you don't have any of this ability to segregate the two and have the effect of full repulsion or full attraction. And so really all you have now is the shadow, the fact that both of them are absorbing energy, but now you don't have the energy going one way if it's red and another way if it's green or any of that kind of crap. So you just have the absorption of energy is what gravity is the movement. The fact that the movement happens in specific rules based on charge gets neutralized because all the charges are doing it in exactly opposite ways, and therefore the net appearance is you can't tell the red from the green. It's all in one color. So the one color, purple, is what's getting blocked, okay, in gravity. And in charge, the two colors are segregated, and they do two different things to the two different elements of the electron and the proton. But anyway, enough. I'm just saying that this answers the question of why stuff moves and how it moves, and that it doesn't have any movement of its own. That if you move an electron, it's because the electron had to be forced to move. It doesn't move by its own volition in any way. It only moves as a force interacts on it. And it's consistent with Newton's observations. Period. And just by understanding the simple concept that it's just exchanging this way for that way. Alright, so till next time. And there's a tendency, you know, to do more this than to do that. And that's all you need to create the imbalances in pressure that we see in the universe. Blah, 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 blah. Alright, enough. So, till the next time, and such. So forth and whatnot.